I thought I'd give you the time to open this session. Anyways, I'm talking to myself.
Okay. Well, welcome everybody this morning, this evening, or whatever it is, time of day, wherever you are. I hope you also saw my email. We intend to put out some type of certificate at the end of the process. And so we will be basing that on you signing in with your name and email, because that's how we're going to know who actually participated in these training sessions. So I see a number of people have signed in. That's great. So we will, at the end of the process, we will go through all the day's chat boxes. So please, by all means, put your name and email address, and we will figure out a way to get your name on a certificate and email it to the email you're providing. I think it'd be good maybe to start with are there any questions from any of the previous sessions?
You can type your questions in the chat box so we can answer that. Well, in the meantime, I can probably start the presentation.
There's still some people coming on, but I think we
okay,
can
just maybe wait another minute or so. Yeah. So yeah, please ask the questions so we can answer. If I cannot answer now, for sure I will email you back. Get into my head.
So we're up to 45, and I think there's still some other people probably trying to sign on, but I think that's a good number. We're a few minutes in, so I think we should begin, Wayne.
Okay. Yeah. Well, good to know. This is early morning here. Actually, in the afternoon, the internet is quite slow. Most people are working online now, and yeah, my son is working. I mean, it's home and playing the game online, so use a lot of bandwidth there. But I think early morning is better, and so it's much faster. So I hope in Asia your internet connection is okay, because that will be the same thing. Most people will be working online. Okay, let's get started. On today's session, we're going to talk about a sample received, sample handling, storage. We will talk a little bit about the standards, and probably talk about the storage condition, temperature monitoring. Okay, so we do the same. We just review, just use some keywords we learned yesterday. So it's just a quick review. So this is the quick review. So we talked about all these. So we talked about the protocol, and we went through the protocol. And we talked about the SOP, and what kind of SOP we need to prepare for the GLP work. We did mention about the reference method versus your working method briefly. We will talk these again, I think tomorrow. We talked about the instrument maintenance. Okay, the routine, non-routine is necessary to be included there, of course, with all the other information. I know we work in the lab, we work on a lot of details, And when we do the work, we just put a maintenance there, and this is typically EPA will question, and they do check this, and they do check something before and after the non-routine maintenance. Communication to the study director is very, very, very important. As I mentioned, as we did a little bit of assignment, we went through NIR4 protocol, and I believe it's more than 12 times. And some people of you may count it, it's like 14 or 15. So it could be, I don't know, but my impression was more than 12. Okay, more than 12. We talked about the detection limit, LLMV, method validation briefly. Also, I mentioned how many times mentioned LLMV. We need to do at least 6 that level. It's in IR4 protocol, and that in that protocol mentioned at least 4 times, I believe. We went through the facility inspection, that checklist, the QA list, and we have very good common sense which checkbox is GLP requirement, which is the additional or scientific requirement. Compliance statement, the GLP, who is responsible, who is the main people control that. I mean, to be responsible for the GLP work in the study. That should be the study director. So we talked about a little bit about the sample storage. Okay, so let's look what we need to talk today. We start something we learned yesterday, and today we do quick Q&A, quick question and answers. And we do the same as we do yesterday. Here's the question. We all know these answers, but let's just quickly go through this. So which of the following requirement is not true about the laboratory operating procedure, SOP, in order to comply with GLP? So A is the approval from the management. B, this should be immediately available, accessible. C, it should be reviewed once in a while. And D, it should describe the QA. And E, the performing non-routine maintenance. So we know that. I'm not going to ask too much. If we have time at the end of the presentation, we will talk about this again. So we just leave the question there. I know most of you should be immediately pick up there. Oops, why it's going there? Did I do right? No. That's wrong. I'm sorry, I did wrong. Why it's coming here? Let me close looks like I did wrong. Let me start again my PowerPoint. Something almost going to the end. Sorry about that. Okay, let me pull out the file. This is the file. And this is what I need to do. Oops, why it's going here right away? Oh, I opened the file to the end. That's why. Okay. Okay. The next one, we talked about those dates. What's the definition of these dates? For example, what is the experimental termination date? Okay, we got some answers there. Okay, it should be the last data collected. It should be study director signs the final report. or this is archiving date, or the last sample disposed. You don't have any sample to work on, or it's in the lab, you finish the lab report. And it should be the same date there. Let's change the date there, the same answers there. So what is the study completion date? Okay. Well, these are very easy to pick. So we have time. We go through this again. We know we are using which GLP to do the work. It doesn't matter which one you go. You just stick to one of them and don't mix the definition. So it should be easy and easy to handle. Okay. Let's go on the next question. Okay. Which study requires GLP? Let's say select all answers. It's multiple choice. It could be more than one. So the pesticide registration, PFAS contamination, food additives, food marketing, and the non-clinical safety study. So these are all simple questions we should be able to pick up right away after yesterday's training. Let's start today's training. We got how many people online now? We got 51. That's a good number. Yeah. Okay. Well, we talk about samples today. Okay. So we talk about sample shipping. Okay. Well, all the samples should be in the frozen condition before they ship to the laboratory. So it depends on the situation. It could be a freezer truck, like a AECD truck in the US and Canada. It could be you freeze them in the laboratory, in the freezer, then you hand deliver to the laboratory if your location is very close to the lab. And if it is in a very remote place, you probably need to ship it by air or other carriers. Then you need to put in the dry ice. Okay. So, for example, if you ship samples, you do need a container. Okay, you do need a container there. And typically it's this kind of the plastic ice chest or ice box, okay, which is have good insulation. And if it is not too far away from the lab, you can hand deliver. So that's good. Also, you need to have the temperature monitoring proper. So it depends. It could be a thermometer. It could be the data log. It could be very simple thing. I know the older days when we ship samples in the IR4 system, we typically make sure this is okay. We freeze a bottle of water, turn it upside down, together with the sample. So if the temperature is above 0 degree, and you will see the water is the ice is going to melt, and you will see the trace of water underneath there. So you will see that. This is a simple way. At least you tell something, but it is important. So we can do a little bit chemistry work to the reaction and why the temperature is important. I remember I did this kind of calculation in one lab. That was when I was in Egypt. I did this one. I remember. So we did a calculation because their freezer was 30 degrees, negative 30 degrees, and their outside the temperature is about 40 degrees. Even in the room, it's about 25, 30-ish. So it's quite warm there. And that's the April time. It's quite warm. So we did a calculation. We figured that out. If you put your sample outside by how many hours, it's probably not good. If we have time, we can go this again. But that what I say is the temperature is very, very important. Doesn't matter this is sample shipping or in your laboratory. Okay. If you ship by air, so you need to put the dry ice in there. So typically the sample dry ice ratio is 1 to 4 by weight. So this will, if you put the sample in this kind of insulated chest, ice chest, or any kind of a like a styrofoam container, the sample should last, at normal conditions, should last 3-4 days. So if you ship it on Monday, and for sure the lab will receive it no problem around like a Wednesday also. Tuesday or Wednesday. So it should be good. So it depends on the distance. If you put too little, it wouldn't last that long. Then you are jeopardizing your samples. Okay. These are the shipping carriers you may use. Well, in the U.S., IR4 laboratory, we used ACDS freezer truck, like similar to this. Actually, it's even bigger than that. We have the samples, put it in there, and this is 24/7 negative 20 degrees in this truck. Okay. So, and this is going continuously through the country, from Canada to US, everywhere. So I know in some countries they may not have the access to this kind of a service. So you probably will find all kinds of the carriers like a UPS, a FedEx, and DHL. So if you ship samples through them, you need to make sure you're putting enough dry ice. So that is important. And dry ice is a solid form of carbon dioxide. The temperature is approximately negative 80 degrees, and it wouldn't go to the liquid form, it would directly go to the gas form. So this is a good way to keep your sample in a very good condition. It's freezing, it's not melting, you don't see any trace of liquid there. Okay. The sample. Okay. When the sample received in the lab, this is typically we start. We don't know too much condition in the field, but when we receive the sample, so when it's in the laboratory, so when you receive that, the first thing you need to check. Don't assume. Okay. We do make mistakes. People do make mistakes. For example, when we receive a shipment, it says this should be cucumber. When we just open the box and open everything and open the bag and see, oh, it's an apple. It happens all the time because when the paperwork showing this is a cucumber, but the field people may have multiple studies going on, and they put it in the box and ship to you. So you do need to check. Don't assume they will do a good job. Another thing is not only look only this is a correct sample, and also make sure this is the right size. Don't assume they will send you the good amount. Okay, so some of them will send you. Well, we typically in the protocol, IR4 protocol, we typically say this is about 4 pounds, which is close enough to 2 kilos. Okay, so in this case, the lab has the good size of sample to work on. If the sample is too small, this is happening all the time. We may see they give you the cucumber, they give you 1 cucumber like this. They give you the apple, 1 or 2 apples more like that, or cherries, they give you 5 cherries. So is it working? Well, technically speaking, that doesn't work because you don't have enough sample to work on. And also, if something like this, something's wrong. But actually, this size small is not the biggest issue. Okay, based on our experience, size big is the issue. I worked in Africa, that's in Ghana. They were doing the mango study. And what they did, because it says it needs how many fruits? 12 fruits, I believe. But the mango is quite big, like this size, so which is about more than 1 kilo, maybe something that big. Because based on like a 12 fruits, they're going to take the fruits there, put it in there, and send to the lab. And you will see one sample is about more than 20 kilos. And well, they have to follow protocol. They have to give a certain amount. Then it's a big burden to the lab. Yeah. So I know some of you may work in the field. Now you need to communicate with the study director, with the field people, with the lab people. Make sure you get to the right size. Too big is not also good. No. Because when you get too much sample size, get a lot of burden in the system. You have to grind all the samples, and how to handle them is a big problem. And you waste a lot of dry ice, a lot of time doing the work. And so this is some kind of thing we need to work together. And also we need to work how we're gonna shrink the sample size. Like we cut them into the quarters, take the opposite quarters, or do we need to cut more? But remember, don't do yourself. Talk to the study director, because there's a lot of tricky things there, a lot of different requirements. If you cut yourself, the sample may not be valid. So talk to the study director before you do it. Okay. Well, most of us are working in the lab. So when we receive the sample in the sample bag, a sample container, that's considered a sample. Okay. So don't remove any portion of the sample. So if it is in the sample bag, it doesn't matter what is in there. Okay. Small size, big size, that's all sample. So you need to process all the sample. So if there's something like, oh, it's too big, too small, talk to the study director before you do anything, because that could be something happening in the field. It may or may not be valid, or maybe there's a mistake, or maybe something is going on you don't understand. Okay, so that's why you should check the sample immediately. Don't wait till the last. Okay. You need to check immediately. Okay. And also you need to take out your protocol to check, because you need to make sure you get to the right sample. This is necessary, because if something's wrong, the field has the time to go back to collect the samples, to go back to do the work again. You don't want to wait like 3 months later. Oh, something's wrong. Okay, based on the protocol, you did wrong. Okay, if it is like this, there's no way you can do the same thing this year. For example, in Michigan, the growing season the window is very small. If you miss this kind of a window, you have to wait till next year. I know in tropical area, sometimes you get multiple growing season you can work on. It's probably a little bit better, but still that's a big change to the working schedule. So make sure you have the form there. Make sure everything's good. Okay, check with the sample, with the protocol. Then of course you need to have your lab number for the sample. Okay, so from now on, it's only a sample. Okay, it doesn't matter it's from where. Is it from Thailand, from Malaysia, or is it from Pakistan or Nepal, or is it your guys working in Vietnam or Laos? So it doesn't really matter, because after that it's only the sample in your lab. It's equivalent to any samples you have. So that makes things easier, rather than just, oh yeah, this is the sample for this, for that. So That's easier because you can use the standard method to do all the work. So from now on, we just look a sample number. Okay. This is the IR4 form. We call that part A, and we typically use the form B. I'm sure we are using similar form in your study. So that has all the information there necessary for the study. So yes, you will receive a form A, a form B, I'm sure C as well, but I'm not going to go through that much. I'm going to just talk about part 8B. So we see that this is a little bit too small. You see on the right-hand side, this form is too small. Let's make it a little bit bigger. Let's say, okay. So we have the trial information up there. So we have a PR number, we have trial number, and also if you send something to through the ACDS, because you put it in the system will give you the bag, and the ACDS truck will drive to your location, pick up the sample. So you do have the ACDS number to put it in there. So in this case, the ACDS number is, okay, AR71, or this is one. So this is related. Okay. So, and also you will see the chemical name, the crop you are working on, who is the FRD, Field Research Director, and all the contact info. Okay, you tell how many boxes there, you send 2 boxes, and 2 boxes, and how many samples. Okay, this is sent to IR4, North Central Region, at Michigan State University in Lansing, Michigan. And down here is the sample information. You have sample A, B, C, and D. A and B untreated. Okay, application none. And C and D, application number 1. And the date, harvest date, and the sample date, and what kind of a sample. This is the whole fruit, and this is tomato, and this is a laboratory ID here. So from now on, these are the numbers in our lab. So that will be called 16175, 176, 177, and 178. Okay, this person needs to sign his name and date. So this is the original raw data now. Okay, so that's information. Okay, let me erase these and ask you a quick question. I know you probably already, a lot of you already did this kind of a form. You have the idea what's going on. A quick question would be, let me erase that. Okay, a quick question is, okay, do you have to separate control and treated samples in separate boxes? Control and treated. Do you have to separate them? For example, in the separate boxes. Okay, please type in the in the chat box there. I saw some answers, yes or no, yes or no. Okay. Okay. Well, when we say separate, here's the thing. Is it separate box, or is separate bags, or it's what kind of a separation? The answer is you do have to separate them, because they may contaminate each other. It depends on the chemical you are working on. Okay, if it is like a volatile or semi-volatile, you will contaminate them if you put together, because those chemicals may go out and contaminate each other. Okay, this is happening all the time. I work in the environmental lab before. Yes, you put some samples together, you will see the contamination, and that's very fast. Okay, so yes, you do need to separate them. Let's see. I have 4 practice here. Okay, you see we have 4 samples, but they sent by 2 boxes. What does that mean? Well, I can see that if they send only 1 box here, I will call the study director. Something's wrong. That means they put samples together, okay, in 1 box. So that means this is 1 box, and this is another box. So yes, it's important to separate them. However, how you separate? For example, if you have the ice chest, and you have physically, you have something in between, because it's built in, separation is 1 box. That's okay. That's workable. Okay? If it is simply dump them together, that's not working. Don't do that. So at least physically, you need to separate them. If you cannot have, for example, if you ship by air, you cannot have 5 boxes. You have to put it 1 box, save time, save cost, and save a lot of things. Then what you need to do, you need to have multiple layer separation. So typically, at least each of them, each sample in the sample bag with another layer protection. For example, another plastic bag or something. Physically put something in between, then another thing, another bag. So multiple layer protection to protect from cross-contamination. So yes, you do have to separate them. So, but how you separate, that's a different question. Okay. Okay, not to be separated if the storage condition dependent parameter. Say that surely, yes, it is depending on the sample, the chemical itself, but the general practice, yes, you do have to separate them. So if you separate them in 2 different boxes, good. 2 different ice chests, good. If it is 1 big box, you have multiple layers, multiple plastic bags, put each other, and have physically you put cardboard or something in between to block them. That's probably okay if the chemical is non-volatile. Yes. Okay, so that's my answer. Michael, do you want to add a comment to that?
No, I think you've addressed it adequately.
Yeah.
We certainly would suggest separate boxes. In most cases, if we're shipping, especially internationally, we do need separate boxes because the amount of dry ice that's required, if you try to put too much in 1 box, with that amount of dry ice, the weight will be too high per box.
Yeah.
So usually you have to separate it.
Okay. Thanks, Michael. Yeah.
It's generally a good practice to have it in separate boxes. In most cases in this study, every country will be analyzing their own samples, so you shouldn't have to be shipping internationally.
Oh, that's much better. Yeah.
That's our goal.
Yeah, that's much better because shipping is pain. It's very difficult. Yeah, internationally, a lot of things, a lot of delay, and that's our work. That's horrible if we lose any sample. Yeah, agreed. Okay. So the basic information you need to put in the raw data package is you need to check. This is necessary. This is a minimum requirement. You have to check these boxes. Okay. You may have more if something popping up. For example, you need to make sure when you receive the sample is frozen. Do you have any sign this is a thaw, or is it dry ice there because you don't know, or is it fresh? Sometimes the field is like 1 kilometer away. You can grab the sample, put in the box, for example, the cooler, and it's fresh and take to the lab. So yeah, that's probably okay, but we don't like that. You still need to count the time, count everything, because everything is moving. So this is very important. You need to make sure you check that. You check it's frozen. And make sure you have necessary paperwork with the sample. For example, you have the shipping form, you have the some information to tell what that is. Okay, and all the samples are there. Make sure you don't want to say I have A, B, but I lose C. Well, you do have D. So make sure, because typically in the form, we see this is like A, B, C, D, 4 samples. Make sure they have everything. And also make sure the sample bag or sample container is good. You don't want to see something is just like broken. Okay. We did some other things, which is some labs may not have the instrumentation, but they do grind the samples. Then they ship samples to another lab. That happens once in a while. And in this case, make sure your sample bottle is okay. Okay, you could, during the shipping, during the carrier service, it may be broken. That means the sample may not be good. Okay, if anything you don't think it's right, just simply write down somewhere, talk to the study director, talk to the field people. Okay, write down all the observations. Okay, it's too much to write. It's difficult to write through mouse. I'm sorry. Okay, so you write down all the observations you have. Okay, so now we have the samples now. What we're going to do, we're going to keep them in the freezer. We will grind them. So typically we do a couple of things. We call that short-term storage and the long-term storage. Short-term storage is just the temporary. It does not mean it's just like by how many hours. It could be by how many days. So typically short-term storage is a small freezer. Okay. If you grind sample, immediately grade. If not, you put it in the short storage there, and you process that immediately. Even you short storage. That's a typo. Sorry about that. Yeah. Even you grind the sample, you have the dry ice in there. So you need to leave the dry ice there, let it to sublimate it, and before you transfer to the big walk-in freezer. Okay, because that's the carbon dioxide there. If you do that, it's dangerous. You're gonna have too much concentration of carbon dioxide. Okay, so well, we are going to talk about the long-term and short-term storage. Okay, so between the sample like there, from sample received to the long-term storage to sample analysis, we need to record all the movement. Okay, as I mentioned before, this is called the sample chain of custody. So we need to rewrite everything. So it's in the lab, it's much easier to handle in the field or somewhere else, because in the lab you just take it from location 1 to location 2, from freezer 3 to the lab location 4, and then you do the analysis, then you put the sample back. So you need to write down everything. Okay. So in this case, if all the sample is moving from freezer to the lab, like a lab space, then you move something grinding or extraction, then put back to the freezer. So this is this cycle. You need to tell the temperature, everything there. You need to tell the temperature in the freezer. You need to probably, most likely, the lab temperature is above 25 degrees, and all those conditions. You need to write it down. You need to have the record. So we can do the calculation. We can do the science calculation. If the temperature is which and how much for this chemical will stay. This is very simple. You just have, these are all constants, okay? It's based on the activation energy, based on the time. And of course, based on what is in there, because you may have changed the pH, you may have to change the water concentration, you have to change other things may work together, like a enzymatic reaction. So at the end of the day, we have time. We do this like a assignment. If we have time, we do that. If not, we just do that next time. Okay. This is typically it's like that. Paste this. This is typically the short-term storage. We have the short-term storage in our lab. And this is just like a big sized. It's very similar to the household freezer. Actually, this is the analytical type of freezer. It's big size and temperature control very well. So we put all the samples there. This is ground sample. You can see all them there. Put the label there. And leave it there for typically for 24 hours. And then we transfer these samples to a long-term storage, like walk-in freezer. Because for the short-term one, the monitoring system is not that good. It is monitoring, it is, but because the size is too small, if it's opening and closing the door too often, people open that, close that, and it's not good for the long term. So this is for the long term. I want to spend a little bit time to talk about the temperature monitoring. Okay, it's necessary to have necessary notes, emergency contact there if something happens. So we put some notes. Okay, if this showing a different temperature, if it is above which number, call this. So sometimes it's mid of night, you are not there, the security may be there, they will find out how to call you. Or sometimes it's the custodian who is swiping the floor and see something going wrong, and they can find you. Okay. Also put a copy of SOP there. We typically paste a copy of SOP just by the location, so people can find that immediately if something happens. And you can see here, we see you see the temperature there is negative 22 degrees C. Okay, and you will see, you will hear the sound if you can set the alarm sound. For example, we typically set alarm negative 10, and if it is this thing going wrong, negative 9, it will give you the audio sound, which is here. Here will give you very annoying sound. If you are in the lab there or nearby, you will not be able to tolerate that too long. So you have to call someone. You have to tell someone because it's very annoying. Okay. And of course, you can change this. You can change it to negative 5. You change it to 0. It's your decision. But this one is just you have to be physically standing in the same room. So on this side here, let's look this one. Look this. Oops, it's going this way. Okay, I did it wrong. Okay. This is, I need to see. Okay, this one. Okay, this one is the phone dialer. We have the, this is the sensor phone. So we have the probe inside there. It's not that accurate, but I will tell if something is going above the setting point. For example, negative 10, this will send send a text message, will call my cell phone. So even I'm home, even I'm traveling, let's say in Latin America, I will receive a phone call saying my freezer is failing. Okay, so in this case, I can call someone, just get it fixed if something's wrong. This happened a couple of times. One time was when I was traveling to IR4 headquarters, and that was midnight, like at 1 a.m., and this called me because the freezer compressor failed, and this is above to -10. So I have to call someone midnight to make sure this is working. Okay, so this is what we have. So we talk about the temperature monitoring. Okay, it's back. Okay, so this is in my lab. We have a temperature monitoring system. On the left-hand side here, this is the old system we have used, I think 30 years now. You will see this window. This is a DOS window. And this still working. This is quite good. And we can take a quick look. Oops. And why it's going now? This one. This, you can see that. Okay, down here is the time. Okay, this is like at noon. And you will see this is negative. This is positive. This is this is a room temperature. Okay, this is a room temperature. You can see here room temperature. This is 21 degrees. Of course, if we can see this is a freezer. This is -20 degrees here. Okay, this is freezer, -19 degrees here. This is walk-in freezer. This is -21 degrees there, with the standard deviation on the side. Okay, so we can tell. This depends on which channel you look. At this time, we look the channel. It should be the room here, which is channel number 1, room 177A. At this time, this is 2013. The temperature, February 14, which is very cold in Michigan. And that was, room temperature was 21 degrees. Okay, so this kind of monitoring, you can see 24-hour profile, what's going on there. This is one system. This system, we are still working, we're using that. This worked very well. Everything is calibrated, worked very well. So that's the DOS system. It's continuously 24/7. Every, I think the reading is every second. Actually, faster than that. It's analog. The data saving is every minute. So every minute there's data there. So you can go down to by minute, which time, which minute, what's the temperature there. Okay, this is one system. There's another system which is the temperature. This is the web system. DOS system I cannot access now. This web system I can access from. Let me try that. Let me put this on the side. I can do that. I can find out exactly the temperature right now in my lab. So at this point, I can do a quick demo so everyone can take a look. This is the one. Let me put this one here. This is a window. Okay. Let me maximize that. I'll go down a little bit. And let me type my IP address. I should be able to tell exactly the temperature. I believe this is 35.9.165.13. I think it's 51, I believe. Okay, so that's almost exactly the same. This is real time. So this is walk-in freezer. This is minus 22.7 degrees. Wow, this is like early morning. Nobody's working there. Okay, so you can see there. Okay, you can refresh that. The number is changing. Okay, it was make it bigger. Okay, it's here. It's negative 22.6 degrees. Okay, so if you refresh that, the number may change. This is another one, another freezer, negative 22 degrees. And if you do that, you see it's changing. It's real time. It is right now, exactly right now, my freezer is like that. Of course, If we don't have any probe or anything wrong, by default, it will give you this number. Forget about that, okay? Negative 99.9, that means there's nothing there. I don't have any probe connected, all these things. Okay, so this is a real time. If something's going wrong there, this is a refrigerator. If something going wrong there, it will send me a text message. It will email me. So right now I'm working. I'm doing this with you guys, and it will send me the text message if something was wrong. So if I travel somewhere, it will send me the text message. I will get a phone call. Let me just put this aside. So this is the real time what's going on. You can always, I can even call right now. I can call, for example, I can call that my phone, because this is pushing. It's getting from the system to me. If I do want to know the temperature, what would happen? Let me see. This is temp. Okay. Let me call this number. Okay, and call. And you can hear that I'm calling this number now. I mean this now. It will tell. Okay. And this is the phone. It's temperature in this.
Hello, this is telephone number 432-0146. The time is 6:54 a.m. Number 125 degrees. Okay.
That's room temperature.
Number 2, 13 degrees below zero. Okay.
Okay.
Number 3, off.
Okay, so the probe is 13 degrees below zero. We don't have to worry about the exact number because you need to calibrate that. And that looks like it's like similar to this one. It's in the defrosting cycle. So it's fine. So it happens. It should be, normally when you call that, it should be negative 20, negative 22. So this is fine. If it is negative 10, it will send me the text message. It will call me. If well, okay, this is, I'm calling back to the system. Okay. So that's the temperature monitoring. It's almost 7. Let's just go through a little bit more before we take the coffee break. We talk about, now we have the samples. Let's say, how about the sample grinding? I know each lab is different. We have, well, I have recommendations, but I just go through 3 or 4 main choppers or grinders, which are all acceptable, but I will tell which one is my preference. Hobart food chopper is used almost everywhere. It's very good. The good thing is the size is big. So if you have 10 kilo samples, you can put a bigger bowl there, and you can grind that with the dry ice, no problem. So it totally depends on the size and depends on the bowl. You can have a bigger one or a smaller one. So this is the open system. This is the open system there. So you will see a lot of coming out. Okay, a lot of like a sample, yeah, small sample size. I mean the particles coming out, but that's fine. That's okay. That works very well. But that's not my favorite. The good thing is this is very flexible, bigger size, small size, easy to handle. So what are you going to do? You open this lid. This is the lid. You open this lid, put everything there. You got the blades this way, the balls go in this way. So it's 3D. So that's good. This is my favorite one. It's a robot cube. This is a small one. This is the 4-liter size. I know Michael just bought the 6-liter robot cubes for some labs there or something. But what I'm using this as an example. So it depends on the size. This is a 4-quart one. Actually, this is not 4-liter. This is quite small. So this bowl is quite small. It worked very well because it's a closed system. It's clean. The noise is much smaller. And the sample you can preserve. You can keep the sample there very well. So, yes, this is kind of a blades. They have certain blades down here Okay, you have this blade. You can have multiple like that, different blades there. Depends. It depends on your machine. The next slide. This is what we have in our lab. This is the 10-liter one. So this one I like the size, the good size. You can have different blades, different bowls to do the work. And typically, for example, our samples, our protocol says it should be the 4-liter. I mean, sorry, not 4-liter, 4 pounds of the sample. Which is around, let me use kilos. That's easier for everyone because it needs to convert. So the sample size is typically around 2 kilos in our studies, in IFO studies. I'm sure in this mitigation study. So if it is normal, I don't say this is super heavy or super light or dry. So it's probably around in terms of the volume, the size, it's probably around the 3 or 4 liters. Okay, let's say. So we put a little bit dry ice there. Dry ice is a little bit heavier. So your size can go up to about 4 or 5 liters. Well, let's say about 4. Okay, sometimes 5. So if your size is 6 or above, you can just do 1 grind. It's good. And this one is 10 liter. So if this is a little bit more, sometimes the field send you more samples. You can do 1 grind. It's good. Or if the sample is very dry, 2 kilos a lot. So you will easily go up to 7 liters or something here. You still can do 1 grind. You don't have to do multiple. And I will show you some pictures in some labs. Because of sample size is too big, you have to grind multiple batches. Okay, so it depends on your machine, and you have to work it accordingly. So I prefer some size like this, and there are some big size like a 50-liter one that's too big because you use a lot of dry ice. So the next one is whitey meal. This is typically for very hard dry, like nuts, like dried roots, like ginseng type. So you put your samples through here, and you grind your samples through here. Okay, you collect the sample down here. Okay, and you have some kind of, depends on the sieve you put it there, you can put a different size. So you can see this there. So the good thing for this is this can grind a very tough one. You could do 1 grind is good. But the sample size, normally you don't get that big. You don't put it like a 10 liter, put it in there. It's difficult to go through. And also, I do like this. What I hate this is the cleaning takes forever. I will have a student spend 1 hour to clean the system. So if you do the dry material like ginseng roots dried, this is necessary. Otherwise, I'd like to go back to a robot coop because it's really taking really long time. Yeah, it's very painful to do that. And every time you can grind a very small amount because you have to go 1 by 1, slowly going through here. So, yeah, this is very powerful. This is really good. It's 7 o'clock. Maybe I just give a couple of more slides before we stop. Okay. The next slide is it's Hobart chopping. So we just showed the picture of Hobart. Okay, and this is Hobart. This is the bowl we put it there. Okay, and depends on the size. You can have big, small. That's why in this case, okay, in our case, it's 2 kilos. That's for sure no problem. It's enough to put the kilos in there. Okay, actually, if you have a bigger size bowl like this, you probably can put like 5 kilos without any problem. Then put the dry ice there. You see the dry ice there. You see. Then you see these are the blades here. So this is a vertical chopping like that. Okay, and this bowl is turning. So it's turning this way. So it's 3D. So it's chopping very well. And this is the lid. You can close this lid and close down here. Otherwise, it's popping everywhere. So that's fine. You're gonna see quite. You can see on the wall. That's why, because this will go up to the wall. That's okay. That's typical. Okay. So when you see the grinding, this is fun to see. You see a lot of smoke coming out of there. Okay, and this is dry ice, and this is a carbon dioxide, and this is you see this on the stage very well. You see something like above the clouds or something. It's like that, and you will see the final product. This is the carrot, and that's good. Okay, so you will see the particle, even though this is a particle, this is dry ice particle with the sample. It's okay. So this is very good sample. It's a very good processed sample. So we take certain portion of that, put in the bottles, and put in the freezer. And that, of course, we have dry ice there. You need to get dry ice sublimated. Otherwise, you're gonna make a very big problem there. It's already 7:04. I would just call the coffee break time. I know some of you may need to have something to eat. It's dinner time in Asia now. Okay, so let's just take 10 minutes break. So we resume our presentation at 7:15 New York time, AM 7:15. Okay. Let me just mute my